Ever think about the clothes you're wearing right now? Where do all those vibrant colors come from? And where do they go? Well, today we're diving into a huge global problem, textile dye pollution. But more importantly, we're going to look at a brand new scientific breakthrough that's letting us finally see the toxic stuff we've been missing for years. So, let's just start with this one number to get us going. 80%. A staggering 80% of the wastewater that's contaminated with these dyes gets dumped straight into our water systems. No treatment, nothing. That's like a massive, uncontrolled chemistry experiment happening in our rivers and lakes every single day. And that really brings us to our first big topic, this colorful but very toxic problem. We're going to connect the dots between the clothes we love and a really serious, hidden kind of pollution. So why is this such a big deal anyway? I mean, it's not just about the water looking a weird color. These chemicals are a real threat to public health. They absolutely wreck fragile ecosystems, and they contaminate the water we need for, well, everything. It's a huge problem, especially for developing nations where a lot of these textile factories are located. Okay, so that leads to a pretty obvious question. If this problem is so massive, why haven't we been able to get a better handle on it? Well, let's dig into that and see why finding these dyes has been, frankly, almost impossible until now. For the longest time, the go-to method for scientists has been this technique called liquid chromatography mass spectroscopy. You can just call it LCMS. It's a really powerful tool for sure, but as you're about to see, it has some pretty serious blind spots. Okay, just look at this comparison. It's pretty wild. The old way, LCMS, needed a huge water sample. We're talking 2 to 3 liters. Then you had to do all this complicated, expensive prep work on it. Can you imagine trying to ship big jugs of potentially hazardous water across the world for testing? It was just a logistical nightmare. But honestly, here's the real kicker. The old method was basically blind to whole categories of these dyes. Things like vat dyes and sulfur dyes, which are super common, by the way, don't really dissolve in water, so the machine just couldn't see them. It's like they were invisible pollutants right there in the water, and we had no idea. And this is where the story gets really, really cool. Let's talk about the new method. It's a much simpler, way more powerful approach, and it all comes down to using lasers. So the tech is called LDI/MALDI. Yeah, I know it's a mouthful, but the idea behind it is actually beautiful and simple. It's what's called a direct analysis technique. You basically just use a laser to zap the dye molecules right out of a water sample and into a detector that tells you what they are. And the most important part, absolutely zero chemical prep is needed. I mean, look at how simple the new process is. First, you take a tiny, tiny drop of water, 2 microliters. That's literally smaller than a teardrop. Then you just put that drop on a little steel plate, you hit it with a laser, and then you match what you find against a database. That's it. So simple, so fast. Of course, you can't identify a suspect if you don't have a lineup, right? So a huge part of this project was building a brand new reference library. The scientists created this amazing database of the unique chemical fingerprints for 58 different dyes. That library is the key that makes this whole thing work so fast. So yeah, it sounds great in theory, but does it actually work out in the real world, outside of a clean lab? Well, let's see what happened when the researchers took this new method out for a spin. Their testing ground was the Loji River in Indonesia, and they picked this spot for a very specific reason. It's right in the heart of the global batik textile industry. They knew if there was dye pollution anywhere, it was going to be here. It was the perfect test. So, what did they find? Using this new laser method, the team found a total of 12 different dyes floating around in the river water. Now, that's already a big deal, but believe it or not, that's not even the most interesting part of the story. This is the jaw dropper. Of those 12 dyes they found, 7 of them were completely new discoveries. 7 pollutants that the old traditional methods had missed entirely. More than half of the dyes in that river were completely invisible to us, until now. And this table basically shows us the culprits they uncovered. See VAT Green 1 and VAT Blue 4? Those are the exact kinds of dyes that don't dissolve in water, the ones the old method couldn't see. And then there's Basic Violet 1, which was basically hiding behind other chemicals. The new laser method found them all. So let's zoom out. What does this all really mean for the bigger picture? This brings us to our last section, why this breakthrough is an absolute game changer for monitoring the health of our planet.
So let's just recap the huge advantages here. You need a tiny, tiny sample. You need zero prep work. And you get a really fast analysis. When you put all that together, you've got an incredibly powerful and accessible tool for scientists anywhere in the world.
I don't think you can say it any better than the researchers themselves did. They said this streamlined approach cuts way down on time and resources, making it ideal for rapid and efficient environmental monitoring. That says it all.
And this, right here, is probably the most important takeaway. Because it's so simple and cheap, this technology tears down the biggest barriers that were holding scientists back. It empowers researchers in developing countries, the people who are right there on the front lines of this pollution crisis, to finally monitor and protect their own water. So, all this leaves us with one last really big thought. This new way of looking at water helped us find pollution that was literally hiding in plain sight. It really makes you wonder, doesn't it? What other invisible threats to our environment and to our health are still out there, just waiting for the right tool to finally bring them into the light?